This video help will continue with question 3 in self-assessment 9 and look at how to use the NORM.INV, or the inverse normal function. In question 1, we were given a data point and tried to figure out the probability using the norm.dist, or the normal distribution function. In these parts, D, E, and F of question 3, we're given a probability and want to work backwards to find the data point that corresponds to. So in question D, we're asked, what are the weights of the smallest 15% of babies born at the hospital? I have the spreadsheet set up to enter the information that we need. We're looking at part D, and the probability that we need to enter is always the probability for the smaller or lower portion of our normal distribution. So in this case, we want the weights of the smallest 15% of the babies. So there's nothing we need to figure out other than converting our percent to a decimal. 15% as a probability is 0.15. Now we want to use that to find the data point. So equals, and we're using the norm.inv, or inverse function. So you can start typing it, double click. Our first piece of information we need is the probability, so I'll click on that cell, comma, again the mean of 112 ounces, comma, the standard deviation of 15 ounces. I've referenced those cells, close the bracket, and press enter. And the data point we get is 96.4535. You're asked to round to the nearest whole number, so I'll adjust that. And what we've found out here is that the smallest 15% of babies born at this hospital have a weight of 96 ounces or less. We can use the same technique for question E, although there is a slight difference. Reading part E, it says, what weights are the heaviest 20% of babies born at the hospital? Our probability that we enter for the normal.inv function always needs to be for the lower part of the normal distribution curve, or the less than portion. So if we're interested in the weights of the heaviest 20% of babies, the corresponding probability would be the smallest 80% of babies. In other words, I did 100% minus our heaviest 20% that we're interested in. So the probability here is 0.8. To find the data point, again, we use the norm.inv function. Our probability is 0.8. The smallest 80%, the weight for the smallest 80% of babies will be the same as that for the heaviest 20% of babies. So we did that conversion, comma, our same mean and standard deviation. Close the bracket and press enter. Again, I'll get this to the nearest whole number, or no decimal places. And what this is telling me is that the heaviest 20% of babies at the hospital have a weight of 125 ounces or more. You can use the same technique for part F, and then remember to insert a text box to write your final answers. Once you're completely done the self-assessment, make sure to check out the solutions and compare your work.